Hey there, Seahawks, it's Miss Adams, and in this video, we're going to go over continuous random variables. A continuous random variable can look different than just like a histogram that we saw with a discrete random variable. But basically, you can still make them with like histograms, but usually they'll have different shapes. So it could be a curve, okay, continuous, because it can take on any value. It can be like just kind of a line. It could go up and then over. It can have some different types of shapes. Okay, those are types of density curves. A density curve is a graph that shows probabilities. The area under the curve is equal to 100% or one whole. Sometimes the density curves take on polygon shapes, so we can use the area formulas to find the area under those curves. Okay, so a rectangle, length times width, triangle, 1/2 base times height. You can use other ones depending on the shapes that you have. If you have that kind of curve, like the first picture we drew, that was more of a normal curve. And we'll learn about those in the next unit and how to find the area under those curves. All right, so our first example, using the density curve below, find the following probabilities. Okay, so you can see that it goes from 1 to 5, and at all of those values, it's continuous, has a probability of 0.25 at every value. So 1, 1.25, 1.0001, 3, 3.001, okay? So the probabilities stay at 25%. Find the probability that x is greater than 4, all right? So if I bring this down, you can see it makes like a rectangle from 1 to 5. Greater than 4 would be this little area here, all right? Well, the length is 1 and the height is 0.25. So I'm going to do 1 times 0.25, which is 0.25. So the probability that x is greater than 4 is 25%. Find the probability that x is less than or equal to 3. All right, well, less than or equal to 3 would be from 1 to 3, which has a length of 2 and a height of 0.25. So it'd be 0.5, which is 50%. All right, this one, using the density curve below, find the following probabilities. The probability that x is greater than 3. So where x is greater than 3, it kind of makes this triangle here. Again, I'm finding the area under the curve to find the probability that I get something greater than 3. Anything in that space would work. So my base has a measurement of 2. My height is 0.6, so it's going to be 1/2 base times height, so 1/2 times 2 times 0.6, which gives me 0.6, which is 60%. The area less than or equal to 3, I have a base measurement of 2 and a height. So for the height, I have to look, well, it goes to 0.6, but it's not going all the way up there. So this is counting by 0.2, so 0.2, 0.4, 0.6. So the height for that orange triangle piece is 0.4. So I have 1/2 times 2 times 0.4. Half of 2 is 1 times 0.4 is 0.4, which is 40%. Again, the area under the curve has to equal 100%. So since I'm accounting for all of the area, I have less than or equal to 3 and greater than 3, I should have 100%. 60 and 40 makes 100%. All right, this density curve, find the probability that x is greater than 2. All right, so when I'm looking at greater than 2, from 2 to 6, if I bring those down, I can see that it makes a rectangle. So length times width, my length from 2 to 6 is 4, and my height is 0.2. So it's 4 times 0.2, which is 0.8, which is 80%. Find the probability that x is less than or equal to 2. So I'm going from 0 to 2. The base measurement is 2. The height is 0.2, so it's 1/2 times 2, which is 1, times 0.2, which is 0.2, which is 20%. And again, 80 and 20 does make 100%, since I'm accounting for all of the area under the curve. All right, go Seahawks.